Alright, we're going to start with number 13. If you haven't watched the intro video to multiplying matrices, the one just before this, I really encourage you to do that. It goes into more detail about how matrix multiplication is done, explaining each step. So I'm just going to assume that you've watched that and go through this a little bit more quickly than if I were trying to explain how to do it. Now we just are going to do it. Okay. So, from the intro video, remember that we're just going to check and see by looking at these two middle numbers when we write down the dimensions. If they're the same, we can multiply them, so that's a check. Then we look at these outside ones, and that tells us, and I really encourage you to write this down, how big this matrix is going to be. So it's going to be a 2 by 2. So, 2 by 2. Right, it's 2 columns and two rows and 2 columns. Okay, so we got something here. We want to fill this in. This is the first row and the first column. So the first row times the first column. So we're going to take that first row, we're going to rotate it to the right. 9 and negative 3. We're going to do 9 times 0 is going to be 0. Plus negative 3 times 4, that's negative 12. Plus a negative 12. Okay, now we move on to the first row and the second column. That's the first row times the second column. Here's the first row rotated like we did just a second ago. First row times the second column. I hope I've been saying second column this whole time. First row times second column. So 9 times 1 is 9. Plus negative 3 times negative 2 is positive 6. So add 6. Alright, now we have gone through and multiplied by all the columns that we see. So now we will be done with that first row right here that we were using, and we'll move on to the second row. Second row, first column is the second row rotated and multiplied by the first column. Second row times the first column. 0 times 0 is 0, plus 2 times 4, which is 8. Second row, second column, second row times the second column. 0 times 1 is 0. 2 times negative 2 is negative 4. So we're going to subtract 4. And now we just need to put all that together. 0 minus 12 is negative 12. 9 plus 6 is 15. 0 plus 8 is 8. 0 minus 4 is negative 4. Okay? So there you go. There is 13. Now we're going to jump back up to number 10 because people get confused about this. And especially in the next one, number 11 that we're going to do, they get particularly confused. They don't know what to do, so I'm going to help you out with that. Okay, so just follow the same process as we did up here. This is a 1 by 2, and this is a 2 by 1. So we can multiply them together by this little check, and we will get a 1 by 1 matrix. Just one number is going to go in here. We're going to get that by taking it's in the first row and the first column. We're going to take the first row times the first column. First row is 3, negative 1. We're going to multiply that by the first column. So 3 times 5 is 15. Plus a negative 1 times 7, that's negative 7. So 15 minus 7 is 8. There we go. Now number 11. This one's probably going to throw you for a loop here. 1 and 4. Negative 2 and 1. So we're working with columns and rows over and over here. And so I want you to think about how many rows does this have. It has one row with just one thing in it and a second row with just one thing in it. This has, over here, a column and a second column. It's that a row consisting of only one thing that throws people off, I think. This is a 2 by 1, and this is a 1 by 2. Okay, so we can multiply them together because these two middle numbers match up, and this is going to give us a 2 by 2. So this is going to be 2 rows and 2 columns. Okay, so we're going to get the thing that's in the first row and the first column, so we take the first row. This is just a 1. We're going to rotate it to the right it's just still going to be 1. There's nothing else to quote rotate. So 1 times negative 2 is just going to give us this negative 2. Okay, first row, second column, first row times the second column. 1 times 1 is 1. Now we move on in the resulting matrix to the second row. So the thing in the second row in the first column will be the second row. Oh, that's not what I meant to do. The second row, which is just a 4, that's all there is in the second row, times the second column, or the first column. Second row times the first column. So 4 times negative 2 is negative 8, and 4 times 1 is 4. Nothing to add together. There's your matrix. That's all there is. So that's number 11. Now let's jump down to number 16. You can just fast forward through this if you want. My writing this down. 3, 0, negative 5, negative 2. They want us to multiply these together. First, we're going to write down those dimensions. This is a 3 by 2. And this is a 3 by 2. Now, these are the same dimensions, both of these matrices, but these do not match up. So we're not going to be able to multiply them. So this is just not possible. And just to show you why, if we went to get the thing in the resulting matrix, if there were one, which there can't be, first I would say we'd start with the first row and the first column. First row, first column. We take the first row, rotate it, multiply it by the first column, but they're mismatched dimensions. They can't work together. We multiply the 0 by the 2, the negative 4 by the 3, but what would we multiply negative 5 by? There's nothing there. So that's why it's really useful to write these dimensions down first and check, can we even multiply these together? And for this one, we can't. Okay. Now, let's go on to number 22. And for 22, A is going to be this matrix. B will be this matrix. Yes, and 22 wants us to do 3AB. 3 times A times B. That's 3 times A times B. Okay. Well, we could multiply these two matrices together first, then multiply by 3, or we can multiply by 3 through this matrix first, and then do matrix multiplication. It doesn't matter. I'm just going to go ahead and distribute this 3. Get 15, negative 9, negative 6, and 12. And still B is just B. All right. Now we're just going to make sure we can multiply these together. This is going to be a 2 by 2, and this is a 2 by 2. And this tells us we can multiply them together. This tells us what dimensions the answer will be, and it will be a 2 by 2 as well. So I have a 2 by 2, and we're ready to go. First row, first column means we'll take the first row times the first column. So we'll write that down. 15 and negative 9. Squish them in there. 15 times 0 is 0. Negative 9 times 4 is negative 36. Okay, now we go on to the first row, second column. First row times the second column. 15 times 1 is 15. Plus negative 9 times negative 2, that's a positive 18. Okay, now we move on to the second row of the answer matrix. So we're going to want to, if we want to find this guy here that's in the second row, first column, then we want to take the second row and rotate it. That's negative 6, and 12 when we rotate it to the right. And then multiply the second row times the first column, second row times the second column. So negative 6 times 0 is 0. 12 times 4 is 48. Negative 6 times 1 is negative 6. Negative 12 times negative 2 is negative 24. Right. And 0 minus 36 is negative 36. 15 plus 18 is 33. 0 plus 48 is 48. Negative 6 minus 24 is negative 30. And there is our answer. Okay, and that will be everything. So it's that matrix multiplication is just a weird thing, but I think if you follow the steps that I laid out there, checking to make sure you can multiply them, writing down before you even start, just putting blank spots to fill in, making sure you have the right dimensions. This one was a 2 by 2. And filling them in by saying, okay, I'm in the first row and the first column, so I'm going to take the first row times the first column. And then it's just a matter of remembering to rotate that first row and multiply it by the first column. That's the weird part, where you would just take the row, and this is a really odd thing. But it's really cool because even though it seems like we're just jumping from systems of equations to matrices all of a sudden, we're going to use matrices to solve systems of equations. To me, it's just awesome. To you, maybe not, and maybe so. But anyway, that's the end of this video. Thanks for watching.